All right, so we're going to continue a little bit with the binomial because, we've got a formula for the binomial. Ladies. And so let me just reiterate the formula for the binomials. The probability of k successes in n trials. In n trials is how we write this. Is a probability that x is equal to k, which we expressed as n choose k times the probability of success to the k power times the probability of failure, which would be 1 minus the probability of success to the n minus k power. Okay, so that'll get you a long way. Except there is definitely a shorter version. And so another way I can do this in my calculator, it's called the binomial. It's called the probability density function, PDF. And the arguments for that are n, p, and k in that order. So if I had, like on the homework problem that overflowed my calculator last night, we have n equals 30, and we have a p of 0.7, and I'd like to know the probability that I get 20 successes. So as to not overflow my calculator, I can do a binom PDF for n 30, p 0.7, k 20. So on my calculator, I find that on the distribution page. Oh, sorry. Okay, sorry. All right, you hit the distribution key, that's second vars. And then you got to go looking for binomial PDF. We'll use it's letter A. Oh, I went too far, so. It's 0 on yours, it's A on mine. Oh, because I have the F's. Oh, I know what I have. It's different. Okay, all right. We have the good calculators. Okay. All right, so that problem was 30, comma 0.7, comma 20. And now you get the answer that you should have gotten for problem 12 on your homework last night, which is 0.142. Okay, so some of your calculators didn't overflow. Mine did. Mine gave me 0. That was an overflow on the calculator. And some of your calculators worked fine. As the numbers get bigger, the more chance you're going to have the calculator overflows. Yeah, often when it says 0, that meant that it overflowed. Okay. So, yes, sir? Yes. Yes, it only gives the discrete. Exactly 20. Yes. Okay. Now we're going to do the cumulative density function. So this is used if I want to find the probability that x is, let's say, less than or equal to 20. Now you could do this. We will in a minute. Okay. So this is going to be the probability that x is 1 or 2 or 3 or 4, that you're looking for a success on the, 0 or 1 or 2 or 3 or 4 up to 20. And you could do all of these separately by formula or with the binomial PDF, but doing this 21 times. But your calculator will give you the probability that your success is on the 0, 1st, 1, 2, 3, 4, 5, up to 20th trial with a binomial CDF. The arguments are the same. The 30 for the N, the 0.7 for the P, and the 20 that I feed in as an argument is standing for less than or equal to 20. We'll do a complement for greater than, so that'll be the next thing that I'll show you. Yeah. Okay. So let me find the key here. Yeah. Oh, what did I do? I went way too many. It's B or A on some of your calculators. See, there's that Poisson that I was talking about earlier. Yeah. The fishy distribution. Okay. So with the CDF, I'll do the 30, the 0.7, and the up to and equal to 20, and get 41.1%. If it's less than or equal to, you use binomial CDF. If it's just plain old equal to, you use binomial PDF. Okay, so that gave us okay. Are the same N, P, and K, where the K means the number you're going up to. Okay? Yes? Oh, okay. Let's do one of those. Let's find the probability that X is less than, I'm sorry, it only went to 30, didn't it? X is less than 28. Binomial CDF only does less than or equal to. So that's the same thing as the probability that X is less than or equal to what? 27. So now I'm going to feed into my binomial CDF 30, 0.7, 27. Okay. The 30 is the N, the number of trials. The 0.7 is the P, the probability of success. Okay. Now you wanted a greater than. If I want to find the probability that we have, let's say, greater than 15 successes, that'd be the probability that we have 16, 17, 18, 19, up to 30 successes, which is the complement of having all the numbers below 16. So that would be X equal to 0, 1, 2, all the way up to 15 successes. So that's going to be 1 minus the probability that X is less than or equal to. Now you got to read it carefully. Huh? Oh. All right. What number is going to cover 0 through 15? What number should I put for my X is less than or equal to? 15. Okay? So then you'll just do a 1 minus the binomial CDF 30.7, 15. Yes, use a little logic, switch it around. Okay.